All right, in section 1.3 here, we're going to take a look at using distance and midpoint formulas. Again, something that you've already seen and should be familiar with, and we're just going to kind of build on the ideas that hopefully you're already familiar with. So the point that divides the segment into two congruent segments is called the midpoint. All right, so for example, if let's just call this segment AB, and it says M's the midpoint. So if we do this guy, M is the midpoint. If we know M's the midpoint, then that means that AM and MB have to be congruent pieces. They have to have the same length. Okay. So if M is the midpoint of the segment above, then segment AM is congruent to segment MB or BM. And so what that means is that the measure of AM is equal to the measure of BM. Okay. So midpoint makes sense. It's in the middle. A point, line segment, or plane that intersects the segment at its midpoint is called a segment bisector. Okay, so if we call this first segment, let's just call it XY. Okay, and then we're going to say that point M is the midpoint, and we're going to say that the segment bisector is line AB. Okay, so AB, line AB, is a segment bisector. Okay, if that's true, okay, and we know that AB is a segment bisector, that means that M's the midpoint, and so it means that segment XM is congruent to segment YM, and the measure of XM is equal to the measure of YM. Okay. Furthermore, over here, I could say, let's call it segment RS. If I call that segment RS, and let's go ahead and say the midpoint, let's call the midpoint K, and let's say that segment KZ is the segment bisector. Okay, so again, if it's a segment bisector, RK and SK have to be congruent. So that means segment RK and segment SK are congruent, which means that they have the same measure. Okay, the other two, we're not going to go ahead and look at. I had those there just in case, but we're not going to worry about that. Okay, and again, segment bisector could be a point, could be a line, could be a segment, could be a plane, could be a ray, for that matter. All right, so example 1 here, it says find AC if AB is 6 centimeters. All right, so AB is 6 centimeters. We can tell by the marks that B is the midpoint, so in other words, line L is a segment bisector. So that means that this piece is 6 centimeters, and so AC, I think it's pretty easy to see using the segment addition postulate that AC is 12 centimeters. Part B, again, line L is the segment bisector. That means S is the midpoint. Okay, we know that the entire length here is 109. Our task is to find ST, call it X. Okay, well, we know that ST and RS are the same. And so we know that X plus X equals 109. So 2X equals 109. Divide both sides by 2. X equals, what is that? That's 54.5 inches. Some of you are probably saying, well, do we have to show all that work? Can't we just divide 109 by 2? You can, okay, but again, I'm going to do everything as thoroughly as possible. And again, this is a segment addition problem, okay? Those two pieces are equal. Add them up. Got to get the whole thing. All right, example 2 here. They tell us that M is the midpoint. Find MH. Two-step process first. Solve for X. Those two pieces have to be equal to each other. Use your algebra. I'm going to do a couple steps here in one. Those 9's cancel, the 2x's cancel, so you're left with 2x equals 14. Divide by 2, x equals 7. Okay? Now, I circle that, but that's not my final answer. Okay? The task was find MH. Okay? MH is 2 times 7 plus 5. 2 times 7 is 14, plus 5 is 19. And I'm going to make sure there are no units here. So if you wanted to, you could just put a U there for units. If you didn't mention units, I wouldn't be too picky. Again, mainly because I did not have units on the problem to begin with. Part B, M's the midpoint, find PQ. Okay, so I know that 10x plus 3 has to be the same as 14x minus 13 since it's the midpoint. Subtract 10x, add 13, cancel. So I get 16 equals 4x. Those 13s cancel. Divide by 4, x equals 4. My task was to find PQ. So PQ equals 10 times 4 plus 3 plus 14 times 4 minus 13. Okay, add all the pieces together. So PQ equals, that's 40. So what, we got 43. This guy here is 14 and 4, that's 40, 56. Okay, so I have 40 and, 43, 56. I'm doing this all mentally, I don't know why. Okay, so what I have is this. I have 40 plus 3 plus 56 minus 13. Let's see here, 43, 99. 99 minus 13 is 86 units. Okay, for the entire length. If you wanted to, you could have plugged this x just in here, figured out what that guy was, and then multiplied by 2. That'd be fine as well. All right, the midpoint formula. You should already know this. The coordinates of the midpoint of a segment are the averages of the x-coordinates and of the y-coordinates of the endpoints. Okay? So for instance, all right, call this guy A, call this guy B. If I want to find that midpoint, call it M. Then I have to average my x's and average my y's. Okay, so in other words, it's going to look like this. I'm going to take my two x-coordinates, x1, x2, divide by 2, and then y1 plus y2 divide by 2. Some people choose just to memorize this formula. You can do that. I always just say average your x's, average your y's for the midpoint. So it says find the it says the endpoints of PR are -2, 5, and 4, 3. Find the coordinates of the midpoint. Pretty straightforward. Okay, so midpoint equals average the x's, -2 plus 4 over 2. Average your y's, 5 plus 3 over 2. That's 2 over 2 and 8 over 2, which is 1 comma 4. Okay, that's your midpoint. We're going to look at some more extensive problems, a little bit tougher regarding the midpoint, where you're trying to find an endpoint as opposed to just find the midpoint. And then finally, the distance formula. Okay, you just have to memorize this one. Okay, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. Be consistent. It's not going to matter anyway because the squared will take care of it for you, but it's still good to be consistent. Okay, so when I'm in example 6 here, when I want to find the approximate length, all right, I'm going to say RT equals square root, subtract your x's, 3 minus -4 squared plus 2 minus 3 squared. That's the square root plus plus, so that's 7. 7 squared is 49. Plus 2 minus 3 is -1. -1 squared is 1. So it's the square root of 50. Okay, that would be the exact answer, square root of 50 units. The approximate would be the decimal. And to be honest, I don't have a calculator hand. Oh, I do have one. So the square root of 50, clearly going to be 7 point something, something pretty small actually. 7.07. All right, so either of those would be acceptable answers. So again, just a reintroduction to the midpoint formula, the distance formula, and how to use them when given coordinates.